MS Ramaya University of Applied Sciences.
Hello students, in this video we will now be discussing Vickers hardness test experiment. The Vickers hardness test, also referred to as a micro hardness test method, is mostly used for measuring the hardness of precision metallic parts, small parts, thin sections or surface hardening depth. In the present setup available at MSR UAS, the load applied is 30 kg and therefore it is grouped under normal Vickers hardness test. A square-based pyramid-shaped diamond indenter is used to make an indentation which is measured and converted to a hardness value. The included angle of the indenter is 136 degrees. As two tangents to the circle at the ends of a chord 3d by 8 long intersect at 136 degrees, it was decided to use this as the included angle of the indenter, giving an angle to the horizontal plane of 22 degrees on each side. The hardness number is determined by the load over the surface area of the indentation. Vickers hardness testing machine includes the following: loading arm with loads, illumination unit, measuring microscope, front optical screen, spindle for supporting the specimen, diamond indenter with an included angle of 136 degrees. Test samples have to be carefully prepared to ensure scratch-free and flat surface. The illumination unit is switched on and the dwell time is adjusted to a maximum of 30 seconds. The test specimen is placed on the support table and the measuring microscope is brought to its working position with the help of the hand lever. The working table is now elevated until the surface of the test specimen is in focus on the front optical screen. The support table is moved around until the right spot for the hardness test on the specimen is displayed. The diamond indenter with an included angle of 136 degrees is now brought into position with the help of the hand lever. The indenter is now brought down gently in contact with the test specimen. The test load slowly increases to 30 kg load. The maximum load is retained until the specified dwell time. After the dwell time is complete, the indenter is removed, leaving an indent in the sample that appears square-shaped. The indentation should be large enough to maximize measurement resolution. The microscope is now brought back to position and the size of the indentation is determined optically by measuring the two diagonals of the square indent. The average of these diagonals are taken and the Vickers hardness is calculated. The indentation in the form of a rhombus is projected on front focusing screen to measure the diagonals of the impression in both axes one after another. The least count of the measurement is 0.001 mm. The focusing screen is divided by lines that are 0.1 mm apart. This can be considered as the initial scale. Any reading taken on the initial scale is multiplied by 0.1. Each of these lines is further divided into 10 more divisions. This can be considered as the secondary scale. Any reading taken on this scale is multiplied by 0.01. Another line marked as 0 called reference line is present on the screen and is used for referencing. This line is aligned with the main scale before taking the reading. The right end of the focusing screen arrangement is provided with a thimble and a ratchet screw for adjusting and fine-tuning the lines in the screen. The thimble has reading from 0 to 9. Any reading taken on the thimble scale is multiplied by 0.001. The reading is obtained by adding the readings from the initial scale, the secondary scale, and the thimble scale. For example, initial scale reading 3 multiplied by 0.1 is added to the secondary scale of 4 multiplied by 0.01, and this is added to the thimble scale of 6, which is multiplied by 0.001. The reading will now be 0.346 mm. Similarly, the other diagonal of the rhombus is measured by rotating the optical screen by 90 degrees and following the above procedure. The final reading D is obtained by averaging out the two readings. This average value is now considered for calculating the Vickers hardness number. Vickers hardness number is calculated by using the simplified formula VHN is equal to 1.854 P divided by D square, where P is the load applied in kgs and D is the average length of the diagonals in mm, and theta is the included angle of the indenter in degrees. Vickers hardness number is reported as 440 HV30 by 30, where 440 is the hardness number, HV gives the hardness scale, Vickers, 30 indicates the load used in kgf, 30 indicates the loading time or dwell time.
Dear students, the name of the experiment is Vickers hardness testing, and the aim of the experiment is to find the Vickers hardness number for a particular specimen. The things needed to conduct the Vickers hardness testing is the Vickers hardness testing machine are the body, the hand lever, the hand wheel, the spindle, the work table, the measuring microscope, the ram containing the indenter, the illumination unit, the lever, the hand lever which is used to operate the microscope, and the ram. By operating the lever, we can bring the microscope and the ram into position. The front optical screen. This is the optical screen where the image of the indentation is displayed. The optical screen has vertical lines, larger vertical lines and smaller vertical lines, and a zero vertical line which is used for measurement. The optical screen is provided with an adjustable nut here to rotate the screen by 90 degrees like this. Then this knob is provided to move the scale provided inside the screen, and this is the thimble which is used to fine tune the measurement. We have two buttons here. These buttons are used to start the application of load, and this red button indicates the dwell time of the indentation process. On the right side of the machine, we have, this is the knob for fixing the dwell time. This is the switch to put on the illumination unit. On the other side of the machine, we have the load selector. This is the load selector from which we can select the load applied from 3 to 30 kgs. We have now fixed the load to be at 30 kgs and the specimen. In this experiment, we are using the specimen aluminium to find the Vickers hardness number. For conducting the experiment, we will place the specimen on the work table. After keeping the specimen, we will fix the dwell time to 30 seconds and switch on the illumination unit. After switching on the illumination unit, the workpiece has to be brought in focus with the help of the microscope and the hand lever. Now the material is in focus. Now we have to operate the hand lever to bring the ram containing the indenter into position. When you hear this sound, it means that the ram with the indenter is in position. The indenter we are using here is the diamond pyramidal indenter with an included angle of 136 degrees. Now the indenter is in position. At this position, a small gap is maintained between the indenter and the workpiece. A sheet of paper should move through between those. To conduct the experiment, I have to bring the indenter in contact with the workpiece. For that, you have to press the start button, green color start button, to bring the indenter in contact with the workpiece. Now I will press the start button. You will notice that the indenter is moving into the workpiece. Now the red color light is on. It means we have adjusted earlier the dwell time. It is showing the dwell time. Automatically, after the dwell time of 30 seconds are over, the indenter comes above. You will notice that. Now, with the help of the hand lever, you are bringing the measuring microscope into focus again. Now when you bring it to focus, it just stands above the indentation. The indentation is now observed on the screen here. Now we have to measure the horizontal and vertical diagonals of the indentation formed. The indentation will be formed in the form of a rhombus. We have to measure the diagonals of this rhombus, take the average and then apply it in a formula and get the Vickers hardness number. While conducting the experiment, you notice that an indentation is formed on the optical screen of the machine. Now we have to measure the diagonals of the indentation. The indentation will be formed in the shape of a rhombus. We have to measure the diagonals of the rhombus to get the Vickers hardness number. Now I am going to explain to you how to measure the diagonals of the rhombus. Now please observe this diagram. The optical screen has vertical lines on that. Those are these blue lines. Those are these blue lines. These blue lines, the distance between two blue lines is 0.1 mm. That means 10 divisions of this forms 1 mm of the main scale. Now, further, these blue lines are divided into 10 divisions. This is shown in red color. That means each division on the optical scale is equal to 0.01 mm. While observing in the optical screen, you will find one more line with a 0 mark. This I have indicated as a green line. This line is also used as the reference line for measuring the indentation. Now if you observe the indentation here, indentation will be formed like this, and you have to align in such a way that one of the blue lines is aligning with the one corner of the indentation. This 0 line should also be brought there to align with the indentation, one corner of the indentation. Now you will observe that these blue lines overlap on the indentation. In this particular diagram, you will see that 1, 2, 3, 4 and something has overlapped. That means you have a reading here of 1, 2, 3, 4, 4 into 0.1 mm. So 4 into 0.1 mm is the first reading. Now we have to measure how much it has overlapped here. For that reason, you have to rotate the thimble. Now I will explain what the thimble is. By the use of the thimble, you can fine tune the reading completely. You have observed that here each blue line is divided into 10 lines, 10 divisions. So each red line is 0.01 mm. That means one smaller division in the optical scale is 0.01 mm. Now the machine has provision to measure up to 0.001 mm. This is done with the help of a thimble. Now each red line division here is further divided into 10 divisions by the thimble. One full rotation of the thimble makes 10 divisions. Therefore, this one span of line here, red line, is divided into 10 divisions. So the least count of the scale is 0.001 mm. Now to make the measurement, you have to rotate the thimble to ensure that this blue line aligns with this line, this corner. You have to ensure that this blue line aligns with this corner. While you are aligning this blue line with this corner, the zero line would have advanced by the same margin. You will observe that the zero line is between two red lines. These two red lines are 1, 2, 3 and 4, between 3 and 4. So your second part of the reading is 3 into 0.01. This gap between the red line and the green line is measured by rotating the thimble. Assume now when you rotate the thimble, the sixth division brings the line together. That means the thimble reading is 6. Now you have to multiply for the third part of the reading, you have to multiply 6 into 0.001. Now for getting the total reading, you have to add all these three. So 1, 2, 3, 4 is the first part of the reading. 4 into 0.1 plus 3 into 0.01 plus 6 into 0.001. So the reading will be 0.436 mm. Now similarly, you have to measure the vertical diagonal also. For measuring the vertical diagonal, the optical screen is adjustable. You have to loosen the screw, rotate it by 90 degrees in the anti-clockwise direction and tighten it, and these lines will be aligned with this position and this position. So initially you have measured the horizontal diagonal. Similarly, you will have to measure the vertical diagonal, and to get the value you have to average d1 plus d2 divided by 2 and use this value in the formula to get the Vickers hardness number. Now similarly, you have to take 3 independent readings and then find the Vickers hardness number and take the average of the values. This completes the experiment.
At MSR UAS, we spark your imagination unlike any other.